Graphing linear equations. First up, we're going to look at what a linear equation is. A linear equation forms a line when you graph it. So today we're going to be graphing equations that make lines. One way to write a linear equation is in standard form, where you have an x that is written first, the y comes second, and the number that's by itself is over on the right-hand side. So the key thing in standard form is that the x comes first before the y. They're in alphabetical order, and the number that's by itself is over on the right-hand side. Keep in mind, we also have restrictions on the numbers in the problem. There can be no fractions and no decimals in standard form. And the first number always needs to be positive. So if you look at the examples we have here, you'll notice that the 4 is positive. The first number must be positive. We also do not have any fractions or decimals. In the second one, you can still see that the 3 is positive. However, the other numbers are all negative. But again, we have no fractions, no decimals, and you can easily identify that A is the number in front of x, which is 3. B is the number in front of y, which is -4. And C is the number at the end, which is -8. Now, when you look at the last one here, this is the one that may be a little more difficult. Most people can discern what A is. It's the number in front of x. And if you think the number in front of x is 1, you're correct. And then C is the number at the end, which is -5. Now B is the number in front of y. But since you don't see a y in the problem, that means that the y must be 0, because only 0 can be multiplied times y to make the y disappear. All right, next slide. Here we have 3 equations. They may or may not be linear. Our job is to determine if they're linear, and if they are, to put them in standard form. So when we look at the first equation, we'll notice that the y is first. So to correct that, we're going to take this -3x and move it to the other side. Now when -3x moves over to the left-hand side, it turns positive. So having something switch sides changes its sign. Now you notice that the 3x is in front, the y comes second, no fractions, no decimals. So this is in standard form, and this is a linear equation. Now let's see if we can do the same thing with the second one. Well, the x is first. It's 5x. However, the y is multiplied times an x. This is not acceptable in a linear equation. So this is not linear. There are several things that you cannot have in a linear equation. One of those is when you multiply the 2 variables together. You could divide the 2 variables. Doesn't matter if the x is on top or the y. We will not have any exponents for the x or the y. We will not see square roots over the x or the y, and we will not have any absolute value signs. If you see anything like this, the equation is not linear. So again, exponents, absolute value, square roots, and or variables in the denominator. Now let's look at the last one. We start with the x. It happens to be first, which is good. However, y is on the wrong side of equals. So let's move that y to the other side. When we do that, the y, which was positive on the right, will turn negative. Now it's okay that the y is negative. It's the first number that must be positive. So we've got our x and y in the correct position. However, we do have a fraction. So what we're going to do is multiply, not by the reciprocal, but by the denominator. Just the denominator will cancel out the 4, leaving you with a 3x. But don't forget to use distributive property and multiply the 4 times negative y to give negative 4y, and 4 times 8 to give you 32. Now we have everything in its correct position. We have the x first, and we have no fractions, no decimals, and the 3 is positive. This is now in standard form, and we can say with certainty that it is a linear equation. Now, before we do any graphing, we need to discuss the x and the y intercepts. Now, the x-intercept is when the graph crosses the x-axis, and the y-intercept is when the graph crosses the y-axis. So please note that this is up 2 on the y-axis. That's why the y-intercept is 2. And this is over at negative 4 on the x, and that's why the x-intercept is negative 4. Please note that the other number each time is always 0. So when you're searching for an x-intercept, you make the y 0. And when you're searching for a y-intercept, you make the x 0. Now let's apply this. But first, let's try a practice problem. Take a look at this sample test question and see if you can determine which are the correct x and the y-intercept. You should pause now. Okay, so if you got B, that's correct. So the x-intercept was at 4, and the y-intercept was at 200, thus resulting in B as our answer. Now let's see if we can make our own graphs. First up, you'll notice we have 3x plus 5y equals 15. I hope you notice that all of these numbers have a little bit in common, because 3 times 5 does equal 15. So we'll start out with a nice easy problem. So let's first solve for the x-intercept. So if we're going to solve for the x-intercept, we need to get rid of the y. The resulting equation is only 3x equals 15. To solve that, we simply divide by 3 and we get 5. So the x-intercept is 5. So now go on to the x-axis and draw and put a dot at 5. Now, to solve for the y-intercept, we're going to make the x disappear by making it equal to 0. The resulting equation is 5y equals 15. To solve that, all we need to do is divide by 5, and we get y equals 3. So the y-intercept is 3, so we're going to go up the y-axis to 3 and put a dot. We can now draw a line through these two dots, and that is how we graph an equation from standard form. All right, next slide. Now, before we go on and do 2 more examples, let's take a look at horizontal and vertical lines. A horizontal line and a vertical line only have one variable in their equations. If you notice, in the first one, we have y equals 4. So we're going to go up the y-axis to the number 4 and put a dot. Now, some people will think we would draw a vertical line here. But if we draw a vertical line, what was the point of going up 4? Instead, we want to go against the axis and draw it horizontally. The reason we do this is because all of the values of y on this horizontal line are equal to 4. So we have the point in the middle, which is 0, 4. We also have a point 5 places over, which is 5, 4. Notice the two 4s? If we go near the end, there's another point, 9, 4. Again, all of the y's are 4 on a horizontal line. And if you went to the left, there's another point over here, negative 6, 4. Every point on the horizontal line has a y value of 4. That's why it says y equals 4. So for an x equals number, we're going to make a vertical line. So we're going to go on the x-axis to negative 3, which is to the left, and then draw a vertical line. So please remember, vertical lines are x equals. Horizontal lines are y equals. All right, the last two slides are two examples. So if you'd like to try this one first, go ahead and pause. Okay, so let's solve for the x-intercept first. So first thing we're going to do is get rid of the y. So the resulting equation is 4x equals 4. All we need to do is divide by 4 and x equals 1. So on the x-axis, I'm going to put a dot at 1. Now, for the y-intercept, I'm going to get rid of my x. The resulting equation is negative y equals 4. So we need to get rid of that negative that's in front of our y. One way to do that is to divide by negative 1. The negatives cross out, and we get a y value of negative 4. So I'm going to go on my y-axis down 4 places to negative 4. And then I can draw a line through those points. And finally, one last problem. So to get the x-intercept, I'm going to make the y once again disappear. The remaining equation is 3x equals 12. Now, if you haven't figured it out yet, all you need to do to get the x-intercept is divide by whatever number is in front of that letter. So if you want x, divide by the number in front of x. If you want y, divide by the number in front of the y. So 12 divided by 3 gives us an x-intercept of 4. So go over to the x-axis, 4 places, put a dot. Now move on to the y-intercept. So take the number that's in front of the y, which is going to be negative 4. Divide by that negative 4 into the 12, and you'll get negative 3. So go down your y-axis to negative 3. Put a dot, and you can now connect the dots with a line. And that is how you graph and write equations in standard form.